This is a quick and dirty little video giving you some help on getting started on your homework in plate kinematics, and hopefully to show you how to navigate the environment of a Mathematica notebook. So first thing we're going to do is we're going to navigate our way to the plate kinematics syllabus and then scroll down to where we have the assignment. It says a Mathematica notebook template for homework problem 1, and if you click on this, it should give you the opportunity to download a file called yourname-hw01.nb, NB being the designator for a notebook. The assignment itself is written out here. It's pretty simple. Just find the decimal latitude and longitude of some point on Earth's surface that's of interest to you and use the Mathematica notebook template for homework problem 1 to determine the Cartesian coordinates of the unit location vector to that point. And so after you download the template, it'll land somewhere on your computer and you can open it up and it'll look something like this. First thing we're going to need to do is rename this thing, because when you send it to me as an email attachment, I don't want the file name to be yourname-hw01, but I would like it actually to be your name. So for example, my last name is Cronin, so I'm going to type in C-R-O-N-I-N, and I'm going to come up here to the File menu and save this thing as, Save As. I'm going to change your name to Cronin and save. Okay, and so remember, saving throughout as your programming helps, especially in a Texas that has lots of power problems at the moment. So mostly what we have in this file to start with are text lines. So I can tell whether a line is a text line by, for example, highlighting part of it and then coming up to the Format menu, Style, and I see that it is listed as a text line, as contrasted with an input line, which is the kind of line we need in order to have the executable part of this notebook. But for the moment, let's just clean up some things in the text. So it says your name, that's your cue to type in your name. Presumably your name isn't Vince Cronin, so put your actual name in there. The date you completed the first version of this, February, whatever it is. As I'm making this video today, it's February 18th. The date of most recent revision, well, we don't need that at the moment because we haven't revised it yet on a different date. Introduction and statement of the problem. Now I've put a little bit of wording in here. You may want to adjust it a little bit. The purpose of the notebook is to compute the unit location vector to a point on Earth's surface that is of interest to you. You could say the purpose of this notebook is to compute the unit location vector to a point on Earth's surface that is of interest to me, for example. I am going to drag through all that and just say I chose a point along the San Andreas Fault in Central California because it shows offset stream courses, channels, whatever. So instead of leaving the prompt that you found when you opened up the file to begin with, I want you to replace it with something that describes what the point is and so forth. Okay, now let's get down to the meat of this. It says input data. This is where I'm going to put in the latitude and the longitude of this point that I'm interested in. And we want the latitude and longitude to be put in decimal latitude and longitude, meaning that it's all in degrees. And so my latitude is the first thing here. So right under where it says the variable lat is the decimal latitude of the reference point, I'm going to put my cursor so that it's sort of lying horizontally, and then I'm going to click. Now I've got a new line. By default, that line is an input line. Okay, so I can start typing lat equals, and then put in the number. In my case, it is 35 point, let me see, 609494, 609494, and I'm going to put a semicolon at the end, and what that does is it we say it suppresses the output, and what that actually means is that when I run this thing, the computer won't just simply print that number underneath the line. It saves me a little bit in the output. Now, just to verify that I've got something in the input format, I can come over to this bracket on the far right side of the screen and click on it, come up to the format menu, come down, style, and see the little check mark is by input. Okay, so life is good. It just by default created an input line. The next bit of input data I need to input is the longitude. The variable long is the decimal longitude of a reference point, it says. So I'm going to put my cursor right below that line. It goes horizontal on me. It's taken a nap. I click on it, and now I can type long equals, and then type in the longitude. So off on the side here, I have a little text file that has that number because I'm lazy. I freely admit it. And so I'm just going to cut and paste. Minus 120 means it is a west longitude. Positive longitudes are east longitudes. And again, I'm going to put a semicolon there. Okay, the next little, so that's all the input data that I need for this bit of code. I have inserted a user-defined function that we talked about in class, and this one turns latitude and longitude, or geographic coordinates, into a unit location vector, and it's called make location vector, and then there's a bracket, and it operates on a latitude value and a longitude value, and beyond that is the code that does all of the heavy lifting. Okay, so we just have that in there below the input data so that we can use it when we need it. Coming down here to computation, we're going to do this in two different ways. First, we're going to do the computation in sort of a longhand way, and then we're going to do an equivalent computation using that user-defined function. Let me just clean up the code here just a tiny bit. Okay, good. So longhand computation, the variables x, y, and z are the Cartesian coordinates associated with the reference point. And you may remember that in class we talked about x, y, and z. And so for my notes, those are the equations I wrote down. So now I'm going to code those things. Oops. X equals cosine of the latitude times cosine of the longitude. So I'm going to come up here under that line. I'm going to put my cursor, I'm going to click on it, and I can type x equals, okay, the trig functions like cosine, sine, and tangent are built-in functions in Mathematica, and built-in functions in Mathematica always start with a capital letter, so COS. Cosine of what, you might ask. And so the argument that we supply to that cosine function is enclosed within square brackets. So it's the cosine of the latitude. Okay. And that latitude is in degrees. In Mathematica, the trig functions like cosine, sine, and tangent want to operate on an angle expressed in radians. So to make that little conversion, I'm going to type in the word degree. So that's another built-in Mathematica function. So I started it with a capital D. Then I'm going to close the square brackets. X equals cosine latitude in degrees times, and I'm not going to put a symbol here. I could put an asterisk symbol or a time symbol or something, but I don't need to. So I'm just going to type cos bracket long space capital D-E-G-R-E-E, close bracket, and then semicolon to suppress the output. Okay, so let's see if I got that formula right. Check back with my notes. X equals cosine of the latitude in degrees times the cosine of the longitude in degrees. Okay. Good. So now I'm going to do y and z and just kind of power through this. Right under that x, I'm going to come down, wait until the cursor goes horizontal, click on it. Y equals cosine, oops, it's cold in my office at the moment, so I'm wearing gloves as I'm typing. Cosine of the latitude in degrees times the sine, oops, of the longitude in degree. Suppress the output. And then z equals the sine of the latitude in degrees. Oops, mistake. The sine is a built-in Mathematica formula function, so I need to start that with a capital S. Yay. Okay, so that's better. So let's just take a peek. Did I make any mistakes? Not this time. So life is good. And then what I would like to do is take that x, y, and z and express it as a set of numbers, or as frankly the set of vector components, and we're going to call that thing result 1. We're going to define result 1 as equals, and then I'm going to put in a curly bracket, x comma y comma z, close with a curly bracket, and semicolon. Okay, now if I haven't made any mistakes, and I make at least one mistake every year, that should give me the x, y, and z components of the location vector to the latitude and longitude that I put in. So that's one way of doing it. That's the longhand way of doing it. But I had that little built-in formula, or I'm sorry, not a built-in, the user-defined function, make location vector. And all I have to do is type that name and then pass 2 arguments to it the latitude and the longitude. So let's see how that works. Let me see if I can get this so that it's on the screen. Okay, so the variable result 2 is the answer produced by the user-defined function make location vector. Okay, that's a nice statement, but until I put in input line, the computer doesn't know to do that. So I'm going to assign to result 2 the following definition. Okay, I'm going to say make location vector. So I'm calling that user-defined function, square bracket. Now I have to feed it the input data, latitude, comma, longitude, square bracket, and suppress the output. Now it's reasonable to wonder if I am supplying latitude and longitude, those are both degrees. Do I need to mess around with putting in this Mathematica built-in function degree as I'm specifying these things? Well, let's just take a peek into that function. And the way this function is written, it builds in those degree functions. So I don't, when I'm putting the input data for this user-defined function, all I have to do is put lat and long, because the function itself handles everything else. Okay, again, if I've gotten everything right in my coding, I should have result 1 giving me the XYZ coordinates, and result 2 should also give me the XYZ coordinates. Okay, so let's see. It says the variable result 1 is the answer computed the longhand way. Okay, I put my cursor below that line. The cursor is now horizontal. The little I-beam is horizontal. And I type the word result 1. This time I'm going to not put the semicolon in because I actually want the output now. See, I'm in the output data section. Variable result 2, blah, blah, blah. Again, I do the same thing. I put my cursor below that line. It turns to a horizontal I-beam. And then I'm going to type in result 2. Okay, no semicolon. And I think I'm all set. I think I've got everything in there that I want to have in there, and I can run the program. But before I do, you know what it's a good thing to do is come up here to the File menu and save it. Okay, so now that it's saved, we come up to the Evaluation menu, come down to Evaluate Notebook, and click on it. And zoom. There's the answer. Result 1 is this set of 3 numbers, x, y, and z. Result 2, computed using that built-in function, is the same set of 3 numbers. So that function seems to work. And life is good. That is the location vector, imagining Earth as having a unit radius and the Earth's surface as being a sphere, with z coincident with the North Pole, x coincident with the intersection of the equator and the prime meridian, and y 90 degrees away from those two. This is the unit location vector to that spot along the San Andreas Fault. Okay, so if you're interested in that spot, you can certainly go back to the latitude and longitude and go Google Earth and type those things in, and it will zoom you right into that little spot along the San Andreas. But for now, that is how to get the homework done. Now, once you have your homework done, you can either send it to me with the answers in there, in which case you just simply save, or you can get rid of the answers, which in some cases gives you a much smaller file to send along the line. So to get rid of the output, you can go to the Cell menu and delete all output. And when I choose that, none of the input is changed, but the output is wiped away.